I think that we opened this file here as our sort of test case for this. Um, I think the idea here is, oh, geez, he put a gist here. I probably should have just grabbed this instead. Helpful. Um, so we have, what do we have here? We have basically a pods definition from Kubernetes. So I guess it looks like we're starting Redis, although this looks like some data that of a pod that is already running would be my guess. Um, okay, so there are two pods. There's a server and a Redis connection. I'm guessing that this is some H server on port 3000. Okay, fair enough. So if you don't need to actually know anything about Kubernetes to like look at this code. It's the point is just that it's kind of like pretty nested JSON so that we can mess with it. And so what we're going to do is we're going to open up this lib project over here because we might need some more stuff. And at the top, we're going to, well, we don't need to import anything. Start using the thing and see how it goes. Okay. First task should be mostly straightforward. Get the API version, which was used to make the call. So let's see here. So API version is under, oh, this is for each of these. So what does it want? Oh, okay. Wait a second. Am I looking at the answers? Oh, okay. So the answers are just here. So we kind of have to do our best to avoid them. But the thing that sucks about this is you're not going to be able to see the question. Trying to. So here's what I'm going to do. I'm just going to copy and paste these in here. We'll actually just close these and try not to look at the answers. So exercises, 15.6, I think. 6. Okay, so we have that. This one. Okay, 3. Copy this in here. Okay, I think that's 6. And we also have a 7 apparently. Get 7, 8, 8. I should check the new version occasionally to see if different here. Whoops. So okay, so we're gonna basically minimize that for now because it had the answers in it, and I don't really want that. It looks like we're live. Things are very slow as usual to catch up, or nobody's here, which is also fine. Okay. Do we actually send this tweet? We did. Wonderful. All right. So first task should be mostly straightforward. Get the API version, which was used to make the call. Um, so this isn't particularly beautiful, but I presume that we want to just grab this. And so that's just going to be key API version dot string or something. So we have just call it A as we kind of normally do, which is sort of weird, but it is what it is. And then we want to try to get key API version, and then we want to look at the string that comes out of it. We're going to need to get this kind of stuff. So 11 is one of them. And then we also need 4. We might as well just import everything so that we can see it all. Okay. So I think that if I just open up the REPL here and then we try and run A. Oh, right. So Kubernetes.a is just version 1, which I think is the answer. We can look at the answer here in a second. Oops, I wanted to press Control-Shift-X. Okay, so 2. Count the number of all containers across all pods. You can assume that every element of items is a pod. Okay, so if we this is not Escape from Tarkov. That is true. But hey, Dom, how's it going? That was super fun last night, by the way. We should definitely do that again. I just can't stay up as late in the future, obviously, unless it's a weekend. It was very, very fun. Okay, so for each of these items, yeah. Well, the issue is just we're on very different coasts. We basically need to, for every items, thanks, man. Take it easy. For every items, there is a pod. Hey, Christian, we need to basically go in to each of these, then grab spec and containers, and then we just need the length of this, I guess. And then we can just sum all of those up. But it looks to me like there's only one containers per thing in this particular case, but I don't think that that's always true. I think that you can have multiple containers um, per definition. Yeah. Okay. So that's what we got to do. Let's see if we can get it done. So items, spec. So okay, we'll do it. We'll do it piecemeal, like how it was suggested to us. So we want to probably look for the key items dot array. Oh wait, we can say, what is it? Num of? I forget what it's called. Let's go find it. Values? No, it's got to be a key, right? Or some kind of key. What's values again? That's an index traversal. I don't think that's what. Nth. No, that gets like the a certain thing. Okay, so we want to do key items dot array dot key back key containers array. Key back key, or I think we need object in here as well. No, we don't. That's the whole point of key, right? Key containers dot array, I think. So I don't think that this is going to work though. But maybe it will. I don't know. Oh, we want to do this. And then reload Kubernetes B. Yeah. Okay. So let's do this. Okay. So that gets us an array Right. So we want to look at the array. We want to look at the objects. We want to look for the key spec. So here's that. So that's an object with a key containers. And let's see what this does. This doesn't work. How do we get back to a key? Confused. Can we just like... That's the thing, is I don't think this does anything. What does this do? I don't think this does anything. Yeah. So how do we like get... Oh, maybe we need values. Maybe that's the key here. So if we do key items dot values, what does this do? Okay, so that gets me the object. So, okay, we need a traversal because we're going over all of these things. Then we should be able to key for spec and values, I guess. Does this work? This is hard. Okay, that works. So we have an object dot key containers. Okay. And then I think we just need the length of, that's the thing, right? So I think we just do length of odds. Like this. Oh, nice. Very good. How's it going? I can't remember. We talked about doxing you. Can't remember if that was okay. Are you working today? I don't think I saw uh anything in Slack or anything. Nice. Yeah, I took the day off as well. Well, the week off. Just I didn't think there were going to be enough people around to make work worth the time, if that makes sense. Like, I need a lot of people to kind of walk me through certain things. So I feel bad like working this week and bothering people who are trying to get their own work done. People who are actually self sustained. Anyway, I think that this is right. Oh, right. Is this correct? I think it's correct. We can just look at the book, I suppose. So this is number 2. Length of key items, values, key spec, key containers, bots. Nice. Okay, so next. Uh, Return the name as text of all containers which have the same value for their image and name fields. Well, that's weird. Uh, Return the name of all containers which have the same value for their image and name field. Okay, so I guess we're going to use this image. Okay, so it's clearly we're only going to get Redis as a list, I suppose. And I also assume that we need to filter by uh index or something. So we'll use the indexes to keep track of things. Okay, so let's see if we can figure that out. So first, we will pods, and this gets us to the containers. And then we need to go over all of those and get, what is it? The image, which we'll use as the index. So key image, I think. So that, reload, C. Wait, what? Oh, that's not right. That's just gonna get the first one. So this needs to be like this. Okay, there we go. So that's what we want. Then we need to like use the index for the image. So it's going to be self index. Wait, I think key is self index. No, it's not. So self index. And then that should keep that. Okay. Then we, oh wait, how do we, we're at the same level. So the keys, I don't know how to look up two keys and like pair them up. Do I know how to do that? I don't think so. Because we now have this. Do we generate? Okay, so I don't think there's a way to like make. We did something in here about. Yeah, so here's the filter by. Oh, okay, so we can just use filter by. We don't even need to do that. And then we'll just focus the key with the name. Nice. So we get the values and we filter by. Key image. I don't know how to do this. So let's look for only in control lens. And let's see what's next to only, because I assume it's probably nearby. Maybe. Nearly? So is there like equal? This prism compares for exact equality with a given value. So, whoops. Okay, so key. Sorry, I keep forgetting what they are. Name and image. So key name only key image. That's not gonna work. I just don't know how to compose these two keys. This works? What does it do? Dude, it does nothing. I don't know how to do this. Maybe that's why the answers are there? I'm not really sure now. Oh, jeez. Filtered. Filtered. So this gives you a value? Then you... Oh, okay. Sure, I guess that makes kind of sense. Key. Name. Okay, so now we have this, so we just want the name as a string. Okay, so that's kind of wonky. Do 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 do. There's probably a better way to do this, but it's too late now. Because we could just do like find dot and then. Okay, so there's probably a macro we could do there. Okay, so this is something that I didn't remember, um, but that's okay. This is a little awkward, I suppose, because like, what if you get nothing, nothing? I presume that these are true. So if you didn't have these keys, you might get things where these are nothing. Oh, but then you wouldn't be able to find their key, so this should be fine. Yeah, I guess this is fine. Okay, cool. That's pretty wild. All right, so let's look at this next one. So collect a list of all container ports alongside their pod's metadata name. Okay, so we're going to use container port next to their metadata name. Okay, so we're basically going to do some swap. We're going to find this and then constantly keep its index, basically, as we go all the way down here, I suppose. So, okay, so we can do that. There's probably a way to like set the index or something. So pods. Um, hang on. So we want something like index or with index from lens. Okay. Indexed. Build a function from an indexed function. I given an index. Takes a long time to find this. Oh, that's a capital I. I just don't know the best ways to do this stuff. I want to just kind of look at the answer, but that's not very helpful. Or that I'm learning anything from that. All right, so let's see if we can do this. So we're definitely gonna want this. But we need to take. We need to set the index, which I don't remember how to do. Re-indexed. Yes, this is what we need. Okay, so re-indexed takes, we just go through the thing that we need. Okay, so we're gonna have key. Sorry, we need values, I think. No. This is going to be metadata dot what? Just dot key name. Key name self index. Um, could it match byte string value to value? Okay, so wait, why does it need to be a value? If we just do string. There's a function that does this. What is it? There's like a decoding thing that we used before. I think it was a prism, but I don't remember which prism it was. Oops. So maybe we can use the string prism to construct it. Maybe you write string. That's not right. And this says I don't know how to turn one of these into that thing. Maybe there's byte string. Okay, I just guessed, but I guess that makes sense. So what's the type of this? Okay, no, it's not a thing. Never mind. So no idea what. Okay, so we gotta figure out how to do this. So let's say byte string package lens traversals for byte string. Okay, so unpack or pack a list of characters into a strict or lazy byte string. Or pack. I think we end this. Keep pressing the wrong button. So this is your data byte string lens. Unpacked cars. I don't understand. Okay, let's just look up what this function is supposed to be. Yeah, that's what I thought. Dot dot string. It's right there. Oh, maybe there's. I just can't stop yet. And then from here. Oh, metadata is under items as well. We're actually not done yet. Oops. So, key items values re-indexed, and then key. Okay, so we got that. We're in items now, and we have that. So now we need to keep going back. Key spec key. No, values. Okay. Values. Okay, so containers, values, and then ports, values, container port. Ports, values, key, container port. Something like this, but apparently it doesn't work. Yeah, so this complains again for this reason. But we could just like remove this for now and then change this to that. This. No, it's still complaining. We get the values and then we reindex. Key items value reindex key string self index keep left. Oh, so like this thing needs to be in parentheses? That doesn't make sense to me. I don't understand. Okay, so we want to keep the index. So let's do that. This is toList of with the index, like I toList of. And then we say key items, values, reindexed. Oh, there's an extra view. I see. Okay, so with reindexed, we need to actually keep going. By just making a lens, we haven't actually like went to go view that thing. So I guess you could also, can you write this as like a section? Yeah, this would be a section. Can I write it like this? I guess it would be like this, wouldn't it? Okay, that's totally illegal, which is a little weird, I guess, but oh, but this is not really what we want. We want that. Okay, so does this work? Okay, anyway, then we do we just keep going. So key container. I already forgot what it is. I guess we can just look because I understand what's going on now. So key spec, key containers. And we'll just keep the left ones this whole time. Values, key ports, values, key container. This does not work. Hey, Sandy, how's it going? Thank you so much for the sub. I really, really appreciate that. Super nice of you. 6 months of subs. Big deal. Hmm. I'm hoping that this would work, but apparently not. So it seems that we cannot like combine these the way I was hoping, and we have to like do this. Oh, maybe that this is just the same thing. I'm not sure. Am I a lens wizard? Probably not. Like I'm trying to be a lens wizard, but it's really hard to be a lens wizard. Um, Chris has worked very hard to become a lens wizard. It's very clear to me. Okay, so this actually does look a little nicer than I think what's here because um I don't know. I guess this is nicer. Oh, but we need to also do number, which is fine. Like this. Yeah, so I am kind of in like a similar boat as you. Like I'm not exactly sure what I'm going to use this for yet, but I do think that it is fascinating. I think one of my major weaknesses with the book right now is that the types are so hard that I just like have a hard like I don't feel confident when I'm using lenses. Like even reading the error messages, like there was a chapter on error messages and it was sort of just my intuition guiding me and not the compiler and types. Like I kind of just knew what combinators go where. So yeah, I think that if I was doing like if you're doing APIs or something like that, I don't see how lenses are going to help you that much. But if you're doing data, I can see how lenses would be really useful. And like I'm just not doing that right now, so it's not that big of a like it's not a barrier that I'm not super confident with lenses. But I do enjoy working through this book. It's very fun. Okay, so I think that this actually looks maybe a little bit nicer than what Chris had. Maybe. I was kind of thinking that this would not work the way that it does. Right? We basically take this index and then just it just propagates throughout. And I wasn't expecting that. I thought we were going to have to do left dot for all of these dots. So that it just kind of like you kind of just propagate the index downward through the lens, but that's not really how this stuff works. So anyway, this is kind of cool. Like we were talking about this last time, Sandy. Actually, like if we had a big glob of JSON that we had never like queried before, I suppose that this could be pretty useful for just like exploring the JSON instead of like I don't know if there's no spec or something. I guess that's becoming exceedingly less common. But I suppose you could use it for like things that might exist that might be more useful. I don't know. I haven't come up with a good use case yet, but having fun with it. Okay, so E, we're going to uppercase the label values inside each pod's metadata. So we're clearly going to want a to list of, we're going to want key items and then something else. So we need to look at that. The label values inside each pod's metadata. Okay. Pod, and we want to uppercase Redis and USA, I guess, if I understand that correctly. Uppercase, where'd it go? The label values inside each pod metadata. Is there one called label? Yeah, I think we're going to go uppercase web and USA for this one. I think that's the plan. Okay, so values. And then so we have metadata. Oh, that's just next. Key metadata. And labels. Okay, and then here is where I need to remember how to do this because there is a way to like go do something on both. Yeah, so this is like this creature size L thing, I think. No, it's not. We want to like split, do something in both sides. But I don't remember how that works. It's like all keys or something. I can't remember. I don't see it in here. There's also a lot to remember, which I think is problematic. Members. I think it's members. So yeah, this gives us text to value. Okay, so now we have all of the values, and then we want to run a function on them. So, well, first we need to look at them, and then we just do, is it two upper or something? Three. Um, so these are text. So two. I don't remember how to do this. Apparently, we're not using this. Oh yeah, we weren't. We need to. Okay, so let's see if this gives us the thing that I want first of all. Yep, Redis USA, Web USA. Um, I don't remember how to do this. I wish there was like just a .f map. That would be really useful. Let's just. Ugh, I'm being so dumb. Of course. Over. There. Okay. All right, but I did something wrong here. Um, does this actually work right? Yes, it does. Oh, right. Okay, so yeah, this makes sense because this this is way too big to print out. Yeah. We're trying to uppercase them. So we want to keep them. Is it supposed to do? Oh yeah, it was supposed to do this. So this is fine. Okay. So great. Uh, so this is going to be similar to this last one. So it's probably going to be a little bit easier. So F odds key items um values so let me do this again. So we want to get to set a resource request of memory for every container. Resource request. Okay. So we need to get to items, values, spec, containers, resources, items, spec, container, resources. Key spec, key containers, key values, key resources, I think containers, values, resources, requests, key, memory, set 256M. I think this is right. So this is Kubernetes F. A little hard to. Oh, I don't actually see it. I probably did something wrong here. So, spec. Okay, so items, we're here. Then spec, containers, values, resources, requests. Is this how this is supposed to go? This is tricky. Okay. Um, what, can this not be key? Yeah, this says at value. That's why we need this object here. But I don't know, this doesn't this doesn't feel intuitive to me. I would have guessed that it would have been key memory set, and then if it didn't exist, it would put it there. But maybe that's not the behavior I should expect. I'm not sure. It's nice to have these examples though, because this is kind of weird. So does it work is the question. CPU memory. So it did the thing this time. Okay. Okay, so get a set of all metadata label keys used in the response. So I think we use the set prism to construct the thing we need. Pods. I think it's like this. Okay, so we need to get to the, what are we getting to? I already forgot. All metadata keys used in the response. Metadata. So we want the metadata name, creation stamp, labels. Okay, so items, value. And then this is going to be, I don't know. How do I get the, it's like members. but let's not try this syntax first. Let's try this and see what this does. Okay, so this gives me okay, so we just want to get all the strings. I think. No, but that's not right, is it? Members are the values. So where do we go? Metadata. So we get, yeah, we're getting the members, but we really just want the index. Okay, what's next to members? Oh, okay, not here. So it's, all right, it's probably going to be in, so members, and it's going to be in lens ASIN. Okay, let's see what's nearby here. Values. So that will get all the, how do I get all the keys? I don't know how to do that. Um, I'm not sure. I don't know. Right, like this gives me all the values that are strings, which is not what I want. I think I want name, creation stamp, etc. Well, I guess we could just look. Members as index. What does this do? Okay. As index apparently just gives me the, what does this function do? I'm not even sure. As index. It's probably not, it's probably just in lens. See if there's a doc string. When composed with the index fold, this yields an index fold of the indices. Yeah, so that's what we want. I don't think we've used that function before, but maybe we have. And then my feeling is that we can just do this. So it's like, give me a list. Isn't this I would have guessed that there's a set prism, but maybe there isn't. I mean, this is a list, so you can just do s dot from list. Oh, we don't have set. Maybe we need set. Um, Restart this. Save this. There we go. Um, I can't. Oh, I have to hit tab. Right. Um, 17. Is there a set prism? Doesn't look like it. I would have guessed that you would have a set prism that takes a list, although I guess it's a little awkward. Okay. Um, this is kind of interesting. Fold map of. Not exactly sure why this is desired. Pods isn't a list, so not really sure what it's about. Okay. Set the host port. What's host port? Is this defined at all? Host port. Okay, it is. So I guess it's only in the one place. So it's like we want to go look for this and set it if it doesn't exist. Isn't that basically the same as what we did before? It's like kind of like this one. Although maybe this just sets it to 88. Yeah, the keyword is unset. So this would set all of them, whether or not they exist. I think I'm just going to look at the answer. I don't. Okay. At host port. Oh, okay. This isn't actually that complicated. So, okay, we could actually write this. Not here. Sorry. I think we can write this a little bit differently and it might read better. I don't know. Let's try it. So, pods is here, is here. Okay, so key items, uh, values, key spec, containers, values, key port. This is like a lot of work. Uh, object at host port by nothing number ooh. Okay, I see. Because right, because it's at host port. We can't actually go to number, I guess. Or yeah, I don't think that's possible. I see why it's this way. Number build 8080. Oh, this takes a lens. Oh wait, maybe I can do that. Maybe I needed the lens there for it to be right. No. Wait, what? Couldn't match type maybe integer with scientific. So so wait, this is supposed to be an integer? Yes. Not really sure what that error is about. That's a weird one. We'll just use the It's fine with me. Actually, this should just be on one line. Okay. Uh, sure. I guess this is it. I feel like I can do this last one, so I'm gonna move this so we don't see it. Maybe because I think I know how to do that. So I think we're. Oh, we have to append the region name. Yeah, I don't think I can do this. I mean, I probably can. I guess you take this and you take this and you put them together. Is there some sort of concat? Yeah. So it's let's see here. So we re-index, we keep this. Wait, but this doesn't thing we want it to do, does it? I'm confused. I don't think that this does what it says it does. It doesn't want to even try to format this, so that's not what I want to do. Oh, okay. Okay. So I think that that's approximately right. So let's see here. So we get key. Oh, it's not even the whole thing, I guess. So let's see if the answer. Yeah, okay. So it's kind of weird because some of this stuff is there and some of it is not there. So I don't really understand what that's about. String. So this is an indexed over. Very, very weird. Okay, so let's see if we can like grok what's going on here because this is weird. All right, so this thing is going in and pulling out the region string and keeping it as the index. That's what we're doing there. Then we go and look for the name of the container. So now we have a basically a tuple of the index and um, the region name and the region and the container name. And then we just stick them together with a dash apparently. And this works, I guess. Oh, right. That's not here. Uh, I. We're looking for the wherever it is. I think it's in the metadata. Metadata name. That is right. Didn't this say? Did I do the right one? Oh, here it is. USA Redis. Am I misunderstanding the shape here? Back. Oh, okay. I guess I think I just misunderstood the shape of what was going on here. But anyway, okay, cool. This is very tricky. So I don't. This is kind of interesting. Indexed over. So the index here is region. The value is, or like the focus is the name. It's interesting to me that this takes a function like this and not a tuple, right? Like, that's kind of strange, but that's okay. Yes. So that's that. That's chapter 15. That's a wild chapter. That's pretty difficult stuff. Um, okay, let's get set up for 16, which is what? Back to this. Oh, I did jump to answers. Turn to questions. Here we go. Bonus questions. There we go. Okay. Um, this sounds already scary. Uh, okay, so first things first, we need to go deal with this. So GitHub. So for reference, if you've not seen this book before, that's the book we're working on. We PF quick. Squash. Merge. Care about this file that I added on accident. Okay. Um, I think I'm. Oh, okay, so I already formatted, so that's good. Um, and then need to make chapter 16 quick. So I don't actually know what we need yet, but we're probably gonna need lens. Okay. So, we're almost set up actually. Not what I should. Whatever. So I don't know what any of this means. So recursive data. Okay, done. Optics are extremely good at precise and expressive data manipulation, minimal boilerplate. But before optics came about, there were a few predecessors. One of the original generic data manipulation frameworks in Haskell was called Scrap Your Boilerplate, and abbreviated SYB. SYB was built upon a type class simply called data, which encompasses a set of generic operations for manipulating and exploring simple data types. By implementing the data type class, schemes allow you to perform you can provide a function which transfers a single node of the nested structure, and the SYB combinators will recursively apply it to every applicable node in the entire structure using one of the several strategies. SIB, or I guess I should call it SYB since it's an acronym. I don't know if people pronounced it SIB. Um, I wasn't doing Haskell at that time. So SYB was a big win at the time, especially when working with compilers, which largely need to run complex rewrite rules across large ASTs. I feel like I need to work on a project that requires something like this so that I understand what this kind of stuff means. Like, I think I understand what it means. Like, you take an AST, like some tree with a given structure, and you use some rules to, like, break that structure down into a simpler one, something like that. But I've never actually done this myself. So anyway, okay. Later on, a library called Uniplate appeared on the scene. Uniplate was developed by Neil Mitchell to improve upon the usability and performance of SIB combinators and had largely the same goals. In many ways, Uniplate simply polished the ideas and interface put forward by SIB. Each of SIB and Uniplate implemented generic data traversals. In essence, they both took an operation and traversed a structure, performing the operations and building up the result. Okay. Once it was recognized that the lens library could provide a clean interface to this type of programming, data lens, data lens, and control lens plated were added to subsume the operations provided by these other libraries with an optics-based interface. It could take a whole book to describe everything you could do with SIB and Uniplate operations, so I'll provide a bird's eye view. Why is this not a book? That sounds kind of interesting. Okay, so control lens plated. The plated module implements all the behavior of the Uniplate library, with an optical interface. Its focal point is the plated type class with the following definition. Okay, so it's a traversal with, because it's structured to itself. The plate traversal takes a self-recursive data structure and focuses its immediate children. It can be. Why can't I speak today? I'm having issues. It can be used recursively to eventually focus all the recursive portions of a structure. For reference, here's what the definition of plate for the list data type looks like. Okay, so handler, we've seen this before. I don't exactly remember the type of this, but we have an X and an XS, so it's just going to take X and then run the handler on everything else, which is kind of weird, actually. How does it, the handler doesn't do anything to the list? Notice that it doesn't focus the elements of the list. It focuses the next child in the recursive structure, aka the list tail. I said that in a different order, but I kind of understand. Um, for one more example, here's the implementation of the tree type from containers. So given a node, we focus the rest. Okay. Similar to the list version, this version calls the handler on each child of the given tree node. Since a tree node can have multiple children, we traverse the handler over each of them. Let's go through some combinators provided by control lines plated. Since plated combinators work specifically on recursive data types, let's define an interesting AST type for us to work with. Use a simple expression AST for adding and multiplying integers. Sure. So we're going to have a value that's an integer and a way to add them and a way to multiply them. Oh, we can just format them like this. Deriving show data EQ. Okay. Well, let's see if it's smart enough to figure out where these things come from. Data. Okay. Derive data typeable. Okay, that's enough to get us there. Then we'll need deriving instance plated expr. So we're going to need standalone deriving. We're going to need plated 5 and derive any class. Thank you. Might have been faster to type that, but I like letting the LSP do the work for me. Okay, so in this example, deriving a plated instance using standalone deriving. Yep, I get this behavior for free by first deriving an instance for the data class from data. This is awkward. There has to be a better name for that, but I don't know what it would be. Um, maybe that, like, naming is hard. Let's leave it at that. Okay, so the first combinator we'll look at is children. It simply gets a list of the direct self-recursive children of a node. Self-recursive children. The only child node of a list is the tail of that list. Okay. I think that makes sense. Okay. It's a list of children. Focus the children. All right. So I'm just going to copy this because I don't. Okay. So let's see here. So val1 is a node. And so each operator in our AST has a child on each side. Oh, because each is an expr. So the right side is 1 and the left side is 1. Fully understand this, but okay. You can see it gets a list of each of the child nodes of the provided value, which may or may not have some children of their own. Children does not get all nodes recursively. It retrieves only the direct children of the current node. Okay, so this is the current node. That makes sense. So the children are the left and the right side of the current node, which is that one. I think that makes sense, I guess. Okay. Next is rewrite. It allows you to provide a rewrite rule, which it will then attempt to run on every node of your structure. Rewrite guarantees that the rule will be applied across the whole structure repeatedly until it can't be applied anywhere in the result. Applying the rule to any and all nodes results in nothing. Applying the rule to any and all nodes results in. So if it can't do the rewrite, it just says nah, something like that. Okay. So are we going to use this to like write these multiplications in terms of additions or something? That'd be kind of fun. I don't know if that's the thing we can do. We'll have to see. Rewrite will ensure the rule is run. Well, I guess we could also say anything uh, with an addition of 0 can just be val or multiplied by 1. That could be an interesting rewrite rule to try and write. We'll have to see if it's available. Oh, it's doing that. Yep, there we go. Okay, so anyway. So given a list, we look at the first 2 elements. If the elements are equal, we keep one and discard the other. Rewrite will ensure the rule is run over all possible tails of the list. It will be run repeatedly, thus also handling cases where an element is repeated more than twice. So, okay, so unduplicate. Okay, this one's kind of cool, but I mean, this is kind of what I was thinking about. All right, so what I want to try and do is see if it's possible to write. Oh, no, because yeah, we'll have a val. I wonder if it's possible to write this. Let's see. So, mult in terms okay, so if we have val in well, how would we write that? We can just fold it, I guess. So we need a function here. We have this here. Um, it's the best way to do this. I don't want to do this right now. We just need to do n m times, but I don't feel like thinking about it, to be completely honest with you. This book is like the book is super great, but I'm just getting it's long. Just getting tired. Is long. Okay, so these make sense to me anyway. So like if we add 0 to any other expression, just just keep the expression on the right or left in this case. And then the same is true for multiplication. If we multiply by 1, it's the same thing as just doing this. So I could see how these rewrite rules would be really useful for particular things. Um, oh, this is not supposed to be. So this should end up just being expression val10. Oh, wait, did I? Oh, yeah, yeah. So stack REPL. So C is removing any duplicates, and then D is val10. Perfect. This makes sense to us, and we are happy. I guess I don't see why we would ever want to actually apply that rewrite rule. I was just kind of thinking out. Okay, so universe. Universe, which is like children, but returns all child nodes recursively. Think of it as enumerating all child nodes that exist anywhere in the provided structure. So, oh, that's cool. I actually wasn't expecting it to behave this way. So it's like all of these are children to tail? Is that what that means? I think so. All of these are children to one. All of these are children to four. Like that. And then this will give us all possible children and inner expression. This expression and then this expression and then val2 and val3. That makes sense. And the entire expression. Okay. Every value of type expert nested within Cosmos is the fold equivalent of universe. Okay. Its definition is equal to folding universe and folds over all child nodes recursively. Funny names. So the to list of is basically just identity for Cosmos, I guess. We could do something more interesting with each of these sub expressions. I don't know what we would do with them, but we could do something. Okay, so next we'll look at transform. How long have I been streaming? Only an hour and a half. Tired. Next, we'll look at not really exhaust. I don't know why I keep saying that. Actually, what am I? I don't know. A snail. Okay. Next, we'll look at transform. It works similarly to rewrite, but performs its transformation from the bottom of the tree upwards. Transform does not guarantee that all possible transformations have been performed in the result. You notice that unlike the operation passed to rewrite, the one we pass to transform doesn't use maybe to specify whether the transformation succeeded. Since the transformation occurs uniformly over every node from bottom to top, there's no need for the extra plumbing. If there's no transformation to perform on a given node, we simply return the object we were passed. That's cool. Let's use transform to swap all additions to multiplications and vice versa. Cool. That makes sense. Notice that we wouldn't be able to perform this transformation using rewrite, since addition and multiplication can be swapped back and forth endlessly. The call to rewrite would never terminate. Transform runs each node once from bottom to top, so it's guaranteed to terminate as long as transformation does. Okay, that's cool. As long as the transformation. Deep is up next. It's a bit more complicated, but it's also more powerful. Here's the type. It's pretty scary looking type. It's like it's some kind of traversal. We can see that deep is a high. Oh, right. It takes a traversal and returns a traversal. It's a higher order optic whose result type matches the type of optic we provide to it. But what does it do? Deep recurses through a structure, trying the provided optic each layer until it finds a focus. It will stop recursing through the tree on any nodes where a match is found, but it's possible it finds several matches on different branches of the tree. Let's try an example using data tree. Okay. Example, because this is actually very confusing. The other ones kind of made sense. Actually, I should write something down about them though. Right. So package containers. Then we should get little blue lines, and we do. Wonderful. So step one, get this tree. Then And we need map. 1. Okay. All right. So one thing that I want to do before we do this is write a little bit about transform. So transform is similar to rewrite, except that it works from bottom to top and only applies the transform once. Rewrite could potentially run never terminate. Okay. All right. So we have a tree, an example tree, and we're going to search through the tree recursively for a node containing treasure. Once we find a node containing treasure, we stop recursing on that branch. We still descend into all possible child branches when no treasure is found. So, let's call this treasure tree. Okay. So that way we don't accidentally run over our T later on, if we even get that far. So treasure tree to list of deep root x treasure. So we need control lens 5. What is root? Okay, it's a lens from 4 trees. So it's saying from the root node, look for treasure. And then because it will also keep going down the tree, right? Yeah, we will still descend into all possible child branches when no treasure is found. So this gives gems, and gold. Why does it not give rubies? Oh, because this is the first one. What if we wanted to keep going? What if I wanted to keep going deeper? Is there one called deeper or super deep? You see what I'm saying, right? Maybe you don't. But the goal is like, what if I could get gems, rubies, and gold? Why can't I get all of them? I don't want to stop. Okay, anyway. Since is a traversal, we can edit the treasure we find. Change both of those to fool's gold. We could, and we would still get this. But I don't. Oh, this is the Cosmos one. Okay, so Cosmo. Oh, let's leave this here. So this will give us gems, gold, but not rubies. Hey, Just James. So this is a pre-order traversal. I wonder if you can do in-order and post-order traversals. I don't know the answer to that. Maybe we will learn here in a second. F to get all children with X treasure, we need Cosmos. Oops. So it's treasure tree Cosmos root x treasure. Right. To reload the REPL or do this thing. I imagine we're probably going to learn about maybe the other ones here in a second. Maybe that's what this overriding plate is. Wonder if there's. We'll have to see. So E, right, that gives us that, but F will give us all of them. So that's kind of cool. Okay, for a traversal which allows selecting all data deep within structures, see biplate. For a traversal. Oh, okay, so Cosmos is a fold, which means we can't edit, I don't think. So if we did, where's the set example? Right there. So if we did treasure tree at set pool gold, this won't work because Cosmos is not foldable. Or sorry, is not a traversal. We need something weaker that allows us to traverse, which I guess is biplate. Four. Okay, well, it doesn't work, but you get the idea. We're gonna have to figure out how biplate works later. Oh, you know what? Maybe it's like biplate, and then this is supposed to be. No, it doesn't work. I don't know. I don't know how to use biplate yet. We're gonna learn about it in a second, though. But we can't set with a fold. That's kind of the point. And we still haven't answered James's question either. Well, I guess it's not answering, stating. Okay. So overriding plate. All the computers we just explored have a plated constraint on the structure. But oftentimes we find ourselves working with data that can't fulfill this constraint. Perhaps the data structure is defined in an external library, and we want to avoid an orphan instance. Or maybe we just can't easily derive plated because our structure is a GADT or contains functions in it. For whatever reason, we can avoid the plated constraint entirely by providing own object will be used in place of plate. All of the above combinators have customizable version of with the of suffix, which accepts a custom child selector. Excuse me. The simplest use to, I guess this is what we'll be using, this uniplate thing. Okay, so biplate accepts a traversal. So let's see if we can do that. So treasure tree, biplate, root x treasure, that equals gold. The other way. I'm just going to try uniplate and see if anything changes. No, it does not. We tried. Keep reading. With this combinator, we can use transform of uniplate directly in place of transform. We can also get a bit more creative and use a traversal we define ourselves. To demo this, let's write a traversal which selects only the child nodes of a tree which pass a given predicate. This will allow us to use all the uniplate combinators, but with more control over how we recurse. Okay. So I'm just going to copy this because I don't want to think too. Why do we need rank n types for that? Oh, it's probably because of traversal prime. That would be my guess. Okay, so I'm guessing that this is a lens. Yep, for all the branches. We know what that is. And then want the root label of the tree to pass some predicate. Okay. Now that we have a custom child selector, we can see how plated combinators behave when only diving into certain child nodes. So we need a new tree. So we'll just call this number tree in case we need to use something later. Okay, and we are on G. Okay, so tree, sorry, number tree, do list of Cosmos of searching off. I wrote. Okay. Weird going on with my chat again. Nice. Uh, number tree, Cosmos of. So build a Cosmos of any root node with a value greater than 5. So it will select the overall tree because this node is greater than 5 and this one, I guess. Oh, and this one, right, because this is also, yep. So 10, 7, 8. I think that makes sense. Okay. Um, search for odds. Okay, I don't need to write that. I kind of get the point. Search for evens, sure. Wait, what? Uh, that's kind of weird. So list all children reachable through paths of odd children. Note that the root isn't filtered. We only run the predicate on children. I'm going to copy this whole thing in here because this is kind of weird. H. That's kind of strange. Even will be fine because it does match, but the odd is the behavior that's confusing. So I'll just leave that. Negate all nodes reachable through a path of even nodes, including the parent. I assume that this will also transform the 10. So let's switch this a little bit. Grab this. All this number tree. We'll search for odd nodes, and then we'll negate the root of the tree. Yep. So it gives us a negative 10 there. Okay, cool. I think that makes sense. So I suppose you can use, well, no, I guess you can't use something like this to change in order or post order, right? Because the first child always comes first and is unaffected. But maybe we can do it here. I don't know. Okay, in the previous section, we learned how deep allows us to find cases where a pattern holds deep within a recursive structure. Deep, unfortunately, has a limitation that it will stop recursing when it finds a match to the provided pattern. Biplate provides a useful way around this restriction, allows you to find all matches within a structure, whether it's recursive or not. How is this different than Cosmos then? I don't understand. Sit back down. So I don't see how that's different than Cosmos. Oh, sorry. It's not this isn't a recursive data structure like a tree. That's the trick. This, that over, move this over, that over. Uh, put this down here, and should be able to reformat this. Oh, that's real weird. Okay, that there. Okay, better. So make lenses employee, make lenses company. I think I'm just using Ormalu. Um, I can double check in just a second here. Template Haskell. Guess we're not using these anymore. So this should be happy. We can reload. Wonderful. So what is it? Config nvim doc settings. We are using Formalu according to this. I don't think that that is, um, although it certainly doesn't look like we're using Formalu. That does not seem correct. I thought the whole point was 4 spaces here. So I think we're using Formalu. Anyway. No, totally fine. You can distract me at any point in time. That's totally fine. Okay, so we derive data so we can use biplate. Here's a company we can work with. That's a weird highlight. Look at that. Right here. See how this works. This is going to give us a very weird set of copy paste. Okay. I think that this is essentially unusable. So this is going to go here. This is going to go here. And then, oh my gosh. This is going to go here. This is super weird. That was really strange. I have no idea why it's formatted that way. Like sometimes the copying and pasting from events is really weird. Okay, so Dunder Mifflin has decided to up everyone's salary by a uniform $1,000. Why would you choose? Oh, I guess okay. Yeah, I don't see why you would choose Toby Flenderson here. Like you clearly choose what's her name? What's the girl that Michael Scott ends up marrying? I think they get married at the end. Um, the heck is her name? I can't remember. It'll come to me eventually. Poor choices, Chris. Poor choices. We don't like Toby. Well, I guess Dunder Mifflin doesn't like Toby. I guess it's more Michael Scott. Anyway. Okay, so update salary boring. All right, so we changed the salaries like this. Okay, it's really ugly, but sure. This is also another very strange set of formatting, which I don't understand. Why would it not do this? Does it try to do that again? Okay, that's pretty weird. Pretty weird. But sure, whatever you say. And obviously this works, but it's boring. This is still far better than what this code would look like without using optics. But let's see how biplate makes it easier. So, what number are we on? Okay. Letter, not a number. Dunder Mifflin. Biplate. Holly. Yes, thank you. Holly. I don't remember her last name though. But yes, it is Holly. Where does biplate come from? Data lens? Yep. I was surprised I couldn't find it. Um, okay. One question is, can we just get rid of this or no? Of course not. Okay, so J. Um, we're gonna change it. Flax. Right. Nice. We're changing it. We like Holly way better. She's a pretty funny character, actually. Ooh. So, that's literally all the code. Biplate infers that our optics action operates over an integer, or an int. And so it finds all ints within the entire structure, even descended into other records. As I said before, with great power comes great responsibility. There's some caveats to consider before reaching for biplate. Let's first let's consider what happens if we make even the simple change from int to integer for our salary field. Oh, it would no longer work, right? Yeah. So if we change that to integer, this biplate would no longer work. That makes sense. Uh, if we add an age, um, it would add 1,000 to that. Sure, very dangerous. Okay, that makes sense. Okay, let's see if we can do this. Have we used ASIN in here? No. Okay, so this should be okay. It seems to be all right as well. So make prisms, JSON, instance, dated, JSON where, equals underscore. Okay, so write a plated instance for this simplified self-recursive JSON type. Try writing it by hand rather than deriving it via data. Okay. What time is it? Okay, I'm good. Um uh we haven't even seen an example of this. Is that correct? This is just using a different plate. Have we seen an example of plate? I don't think we have. Okay. Oh, we have. I just don't remember it. So okay, so in these cases, the handler doesn't matter, right? Because there's nothing to go traverse over, I guess. So in the list, um, don't we need to traverse this whole thing? Mm, okay, so import control lens hiding list. And then traverse. Okay. So what is X? What is X is a good question. I guess it's then just this. Okay, let's get rid of this. Okay, so first this is wrong. I'm guessing that we need to return list excess like this. What does handler excess does this compile? don't really understand what this is supposed to do. Oh, well, first of all, it needs to be there. Couldn't match type. I'm very confused. Oh, can I do type applications here? Let's find out. I don't really understand what's going on here. Type applications. Expected type f of JSON, actual type. What? What are these things supposed to be? I don't understand this. This one doesn't make sense to me. Like, what would I put here? How do you figure out what the end is? If you have an empty list, how do you derive this? I don't understand. We're going to look at the answer, I think. Doesn't make sense to me. Does anyone have any ideas before I look at the answer? I don't know what to do with an empty list. Like, how would I get this to be a JSON? There's no way to derive some empty thing. I don't have a clue. Doesn't make sense to me. Okay, anyway. Um okay. That's not what I was expecting, to be completely honest. So okay, so we what's the type of our handler? Okay, JSON to F JSON. So we have list of F of JSON, and we want F of list of JSON. Then we want F of list of JSON. So we have a list of JSON that we want all to be a list. Okay, I guess that's fine, but that's still weird to me. Okay, so we still have these correct, and then I already kind of looked at the object one, obviously, but it's a map. So I guess it's basically the same thing. I mean, it makes sense that it's the same as this one. It's essentially the same functor. Or, well, it's a different functor, excuse me, but it's the same concept. Traverse will end up giving us the map of the JSON instance, right? So we just want to map our objects over that. F map specifically, not this map. Okay, sure. I think this is kind of makes sense. Okay, good. There's no answers here, which is nice. But anyway, this gets derived for us, I suppose, which is really nice if we just write an instance for it. If we derive data and then just write instance plated JSON, we should be okay. Or derived instance with standalone. Okay, so flatten objs is gonna take a JSON to maybe JSON. And we're gonna write this. We're gonna have a JSON object like so. And then we're going to have HIJK be this. Okay, so what's the idea here? Flatten objects. So we just want to get all the values from an object. Yes. So if we have an obj m, we're going to do something. Otherwise, nothing. Okay, so if we have an m, we're just going to m dot values m. Is that what it is? M dot, I don't remember how to get this. So map a b to list b. It might be fb or something. Um, elims. And then we need to embed those in a list. Oh, and then we need to I guess like this. So pure just gives us a just. So like I don't know, sometimes I like to write pure and then other times I think it's maybe less readable to do it that way. Like this is probably more readable um, than what I had before. I think. Okay, so then in theory, does this work? Not in theory, does it work in practice? uh, so we get a number one, and we get string tweedle, string twiddle. Okay, so use Cosmos to get a list of all the string values in a JSON structure. Don't collect string keys. Use Cosmos to get a list of all string values in a JSON structure. Um, why are the answers sometimes here? I don't understand this. I don't know what that's about. I'm very confused by that. HIJKL. So we want to use Cosmos. We want to use to list of. Probably want to use like dot stir, I guess. So it's probably like JSON obj to list of Cosmos dot stir. Is that the right answer? We only want strings, right? Tweedle twiddle. Don't collect string keys. Yeah, so I guess that's it. We have the answer here, but I think we can figure it out. What is JSON stirs? I don't know what that is. So anyway, this is confusing to me. But anyway. Oh, wait. Yeah, this looks like a completely different example, actually. I don't know where JSON stirs is. As far as I can tell, it's not here. So I'm not really sure. But anyway, so we have this object, and then we just want to look for all the strings, and then we want to reverse them. So I guess it's like this. Can't use Cosmos here because Cosmos is a fold. We need a traversal, and deep is a traversal, apparently. We could also use the what's the other one? Not not deep, but forgot the name. Transform? Is that what it's called? Deep. Oh, okay. Cool. We could use transform as well, because deep would not actually do. Okay, so deep wouldn't deep stop if I had. Well, anyway, we'll see what the actual answer is, but um, should this really be transform F JSON obj or something? Yeah, we'll just put a question mark here. I'm not really sure because then you could find every string and then transform them, but you can't do that with this one. This would only find the first string in a subtree, I think. So I don't think that this works quite right, but maybe I'm misunderstanding the way this ends up working. Okay, so oh, I also should probably put the questions that I'm working on here before I. So one is this one. Implement plate for JSON. Two, write, rewrite rule to flat objects. Okay, read. Use Cosmos in a list of all strings. Use deep to reverse all strings in JSON. Something like that. Let's just put a dash. More sense. And then up here, we'll write okay, 5. Use byplate to get a list of all characters in the following structure. And use byplate uppercase them all. That's not what I should have done. Okay, so structure. The weird structure. Okay, and then we need biplate. Look at an example of biplate. So, okay. So I guess we just get biplate instances for like nested structures like this. We just look at a biplate example again. So what are we at? MN. So I guess structure biplate. We just want the strings. So, okay, so N needs to have the type no. N needs to have the type list of string. Is this supposed to do? All a list of all characters. Okay. So this is going to return a string, and we want play. Uh, list of all characters in the following structure. List of all characters. Won't byplate replace the things in place? I don't understand how I get just a string out of this. That's how I'm interpreting the question. I think the second one makes more sense. So the second one, um, I'll put an undefined here. MNO. So O will have the same shape as this. And O will be structure at biplate over fmap. Sorry, we could write traverse to upper, I believe. And then we just need 3. Okay, so this needs to be a string to, or sorry, a data S. So I think it's this whole thing. Maybe we write a helper. Like biplate S is I mean, I guess we can just put these in here. This is probably fine. Oh, right. And then let's just a second. So let's do this. So here's the structure that we're trying to use biplate over. And let's remove traversed and then just do fmap to upper. Okay. So okay. I think I know what we need to do. We need to say type structure equals this. Deriving instance data structure. Overlapping instances for data. Okay, so that already exists. That's the point, I guess. So we should be able to just write structure. And we want to remove 5 to doing. Okay, so it's having a trouble with functor. So I guess it's fmap like that. This work. Yeah. Okay. So for this one, do we just do structure to list of biplate string? And biplate will be structure. No instance for typable a not. Typable a is what? A string? Okay, so that doesn't exist anymore. And this will give me a list of string. So let's look at what that is. I don't know what this is doing at the moment. Okay. So now we have biplate. Can we get rid of this? Yes. So we've we've done this. So it's like traversed. What is nub? What is it called? It's nub, right? What does nub do? Forget. I'm pretty sure that it does what I think it does. It's a weird name, which is why I always forget about it. Yeah, so it's doing what I want, I guess. What is this complaining about? Do I even need traversed here? We don't want this. We want that. But this isn't quite right either. Is it? No. Um, is this right? Oh, I'm literally just guessing at this point. What does this one do? I think that this just gives me all of them. So what if we traversed? Okay. Not really filtered by though. It's supposed to be over nub and then what is it? This. This doesn't work. This is a maybe. So what's wrong with this? Something about oh, being silly. Wait, no, I'm not. Okay, couldn't match type list of A with character. This one's tricky. Is this one supposed to be filtered by id? No instance for monoid character. Okay. That was a pretty common error. Oh, that would just give me the first thing. I want all of them. I guess that's what this is for. But this will just give me all the characters, right? I think I'm overthinking this, and I should just use nub outside. Because, like, if I just do this, I don't even need traverse. I can just use the biplate. and then it should. Oh wait, that doesn't work. I need dot traversed. There. But really, I also need this. No. I'm so confused. What is this now? That's all the characters. So if I just nub this and fmap to lower, I thought I tried this, but it didn't work. And then sorted, I suppose. This comes from how do isn't it sorted? Thinking of Python now. Sorted? Where's this come from? It's probably in data list, right? Sorted. Keep pressing escape, which is kind of funny. What's the quickest way to sort a list? There, sort by? Yes. Is it just sort? Yes. As long as they're orderable. There we go. So does this work? Sure. And I would like to remove this and this if possible. Okay. That was a little awkward, I think, but let's see what the answer is because I'm genuinely curious what Chris does. And maybe I was overthinking. I was overthinking it. Okay. It's not list all the unique characters, just list the characters. So this is all we have to do. We do need the traverse though, don't we? I think we need this traversed. Or is the reason that this doesn't work because I put string here? And if I do n string, okay, so it's kind of, that's interesting that it works this way. So that's kind of cool. I kind of want to leave this here like this because I think that this is arguably weirder. And I'd like to think about it later. All right, and then this one needed some help with the types. I'm surprised that this just works. Again, GHCI does some weird stuff. Well, I shouldn't say it does weird stuff, but it does something slightly different when it comes to type inference, it seems. Like it's a little more clever about type inference. Okay, so for everybody new, I see a few more people hopped in. Hey, unfortunately, we're finishing up, but we're messing around with this interesting function called byplate, which does some extremely powerful and arguably dangerous transformations with data, and it's pretty interesting actually. So we're next time, which will be tomorrow for sure. We're gonna work on this chapter, generic lens, which looks to be about well, it's 10 pages exactly, so that shouldn't take us very long to get through. And then we're gonna move on to starting a new project. Um, probably. Let me see this calendar. So yeah, tomorrow we're gonna do that, and then I'll have to decide if I want to stream on Friday or not. We'll have to see, but that's kind of what I was thinking. Hey Chris, how's it going, by the way? No, I actually think the biplate examples are kind of interesting. Like this is a little weird to me because like you have your. Let me show you the answer just so you see both next to each other. Just got back from a hike. Nice. How was the hike? Was it good? I wish I went on a hike. So it's like okay. So I think it's pretty wild that this works at all. Uh, like it's pretty cool that this works. A bit cold though. Yeah, we sort of we were talking we is my girlfriend and I. We were just trying to decide earlier if we wanted to go for a walk. And we ended up not doing it. So one thing I want to try real quick is the following. What if we change this to at car? Nice. Very cool. Um it's interesting to me how this works. Like biplate is clearly a very cool uh, function, but it also is very powerful. But I do want to change this to OP. So if we do biplate string, that shouldn't do anything. The question is, do we need this still if we put string there? We do not. So it's smart enough to figure out that it's a list of string. So that's cool. If we do character, can we do this? Very cool. So so a few variations of this I want to write. Um, so we can write string f map to upper. Whoops. R. Did I not copy this as well? We can also write this to sort of coerce it into using the string instance, I believe. So if we look at biplate here, my guess is that, oh, okay, it's actually, well, I mean, it's not in HLS, but I'm guessing that by writing this, we're coercing A to be a string, basically, which is why this works. Oh, wait. Yeah, we must be. Mm, I think so. Because if we write at string, I think it behaves. Yeah. Okay. So it's sort of interesting the way we're making the type inference work here. But we don't actually need this if we put string here. So yeah, need to give GHC a little bit of help in these certain situations. But this is super neat. I So I'll just put a note. Type inference with biplate can be a interesting beast. Check out these examples below where the types of biplate influence the result. Very neat. Okay, cool. So I actually really like biplate. Um I like this uniplate chapter. I would like to find a good reason to need it. Like to use it, I mean.